Everybody have a seat. All right. Shh. So I'm gonna show my screen. All right, so kinematic. Kinematic is I'm just gonna talk about projectile functions. Projectile function is important for things. Hold on a second, let me see what's my Thank you. All right. For yeah. Thanks to my IT guy. You know, I love when they call you and my name is John Smith. And they're like an Indian scammer, and I'm like, you don't sound like that. I'm sorry. Huh? I don't know.
It started with that line with this Y right here.
Hey, John Smith, I need something is not connected. I don't know what is not connected. Is the HDMI? It's not connected.
Yeah.
Oh, see? All right, so we're gonna look at this particular questions here. So I am gonna open a QuickTime. I'm gonna open here. Oh, great! Nothing's working today. I'll restart.
No, I told you.
All right, so a ball is thrown upward at the top of a 180-foot building with the initial velocity 96 feet per second. Determine the function, position, and velocity function of the ball. Find when the ball reach maximum height. Find the maximum height. Find the instantaneous velocity. So this pretty much this is the actual test, by the way. So you are gonna have the same question but different number. Pretty much. This is the only time that I'm going to tell you that you're going to have the same question with different number. So let's think about those things. First of all, think about gravitational constant. So for me, if I would import this to here, import, open notes. Okay, so I don't know if you guys ever seen the movie Journey to Center Earth. I love the movie, by the way. Pretty creative. I like Brendan Fraser. He's a pretty funny guy. Um, so there was a scene that they were traveling to center of the Earth. So they go into the cave, and it's pitch black, and they cannot tell how far the cliff down. So he decided to, how did he measure the height of the cliff? Because he have the rope of 400 yards, 400 feet. How do you decide the rope? How do you decide the cliff height? Because what if your rope is 400 feet, but your cliff is 800 feet? So that means you're gonna go all the way down and hang halfway, and that's not good. So how did he measure the height of the cliff? I know Krishan knows, but how about everybody else? How do you measure the height of cliff? Two people know? Let me ask Elsa.
We measured the amount of time it took for something to land at the bottom of the cliff.
Good. Okay, so what he did was, I think it's a glowing stick or something like that. Is it? It's a glowing stick?
Yeah, it was like I think it was some type of light.
Yeah. And he just throw it and they hear the sound when they hit the landing and count the speed. So, but how did he measure how fast it is? If it takes 5 seconds, do you know how many feet is it?
Well, how fast is gravity?
That's a great question. How fast is gravity, right? Okay, so if it takes 5 seconds to land, that's actually 400 feet, exactly. How do I know that? Well, it turns out the gravitational constant for physics is 9.8 meter per second. So in physics, is 9.8 meter per second square. In calculus, we don't use 9.8 meter per second. We use feet per second. So if you type in a Google, you convert 9.8 meter is equal to 32 feet per second square. So that's a gravitational constant. It doesn't matter you're in China or here. Depends on region you go to. They all have the same gravitational constant. Now, do you know how much is the moon?
I think it's around 1/8.
It's actually 1/6 of the Earth.
Mm.
It's 1/6. Oh, you're pretty close. 1/6 of the Earth. So if you drop something over there, it's gonna be 1/6 of that. I don't know what's 32 times 1/6. It's probably like 5 feet per second square, something like that. Now,
it would be 5 plus 2 over.
in
5.
physics, we use 9.8 meter per second, and that's why the function that you see in physics is actually they use 10 rather than 9.8 because they can do math over there. I'm just kidding. So they actually supposed to use something. Now let's talk about free fall. If it's something that's free fall, that means there's an equation. It's gonna be exactly half of gravitational constant square. Half times g times t. G represents constant. So since we know in physics it's 9.8, so that's why they got negative 4.9 t squared or negative 5 t squared. Do you guys remember that in physics? No?
Sorry, could you say that again?
Okay, so this is a 32 here, t squared. So that is equal to 16 t squared negative. So this means, this represents how far they fall. Depends on the time. So if I use time and if I use h of t, if I do 1 second, it's going to fall exactly 16 feet. If I for 2 seconds, 2 squares, so it'll be negative 64 feet. Does that make sense? 3 seconds, 3 square is 9. 9 times 1, 16 is going to be negative 144. 4 seconds is a 4 square, 16 times 16 is 256. And 5 seconds is going to fall exactly 400 feet. Now in physics, this one is, so in physics, it's going to be half gt squared, so half times 9.8 t squared, so that's equal to 4.9 t squared. Do you remember in physics you use 4.9 or 5? No? Nothing? How do you feel physics? Oh. Okay, so in physics, it's gonna be you plug in the t, whatever it is. So this is called free fall. So there's a free fall part. So there's a 3 component in the position function. The first component is the things always fall. So in position here is in here it's gonna be, we're gonna call this function h of t. H of t is equal to, or h of t or s of t. So I'm gonna use s of t for position rather. So s of t is always the free fall part, which is negative 16t squared. So this is the free fall. But if you have projectile, you must have an initial velocity times time. So v0 times time. So this is the initial velocity. This is how fast you're throwing up. So how fast you throw up. This is v0t. v0 means initial velocity plus s0. That's initial positions. So you must have those 3 components. One is free fall. It doesn't matter what object you throw. It's always something. A basketball, a golf ball, a feather. You're going to say feather doesn't fall exact same time as the golf ball. You are true. It's air resistance. But if it's in vacuum, then feather is going to fall exact same speed as a golf ball. Have you seen the video of they put a feather in the bowling ball in the same room and they suck all the air out and they let it fall? They fall exact same speed. How many of you guys see that video before? I show you
the video where the dude was on the moon, dropped a hammer and a feather at the same time.
Yeah, because it's almost vacuum there. Well, it's vacuum. I show you video when?
Last year.
Oh, not this year though, right? Not this year. So it's a very cool video by BBC as a physicist. I forgot his name. He's very well known as well. Not Neil deGrasse Tyson, but the other guy. I like him. He's pretty cool. He went to a vacuum chamber and he dropped 2 things and they fall at the exact same time. And what a surprising thing is, most of physicists know that's gonna happen, but they still very impressed of that actually happened, see in front of their eyes, because it doesn't seem as true. There's no way that you think a feather is gonna fall same time as a bowling ball, but you can see it on the video. Ethan's looking at it. Okay. So the position function is always gonna be s of t is equal to negative 16t squared plus, in this case, initial velocity is 96 t plus the initial height, in this case, is going to be 180. Does that make sense? How do you find velocity function? Those of you guys in physics, you guys should know. How do you find velocity function? William's like, I learned nothing last year. Okay, you take a derivative. If you take a derivative, is s prime of t, which is v of t, which is equal to negative 32t plus 96. So you can figure out a position function and also velocity function by taking derivative. Now, here's my first question. Find a time when the ball reached maximum height. How do you find that?
Um, 0.
Okay. A bit.
The whole derivative.
Okay.
I think it actually is for me to it around.
Now here's the question. A bit says double derivative. Elsa says, now who's right? Elsa says, I'm right. It's not double derivative because double derivatives is actually acceleration. If you pay attention, if I take another double derivative, this is v prime of t. So s double prime of t is equal to v prime of t is equal to negative 32. What is negative 32? What is negative 32? The gravitational constant. So that's why the gravitational constant is acceleration of an object. Okay, it's falling at negative 34 feet per second squared. Now, how much time I have? 5 minutes. Okay, so let's ponder what Elsa says. Okay, I'm gonna do that tomorrow, but I'm gonna throw something at Elsa. Sorry, Elsa, you better be able to catch, right? Okay, so imagine somebody recorded. So you want somebody to record it? You can record it so I can get fired for doing this. I get fired for doing this. Okay, I want you to record in a certain way though. I want you to record in a way that is slow motion. Slow mo. So you can get me fired by showing this the principle says, look, this is a snowball of something. Okay. So the problem of slow-mo is this. The problem of slow-mo is you cannot click too early. You had to click 1 second earlier. Okay, so I'm gonna say 3, 2, 1, and then after 1 second, I'm gonna throw. Okay, 3, 2, 1. Okay. Now, did you record it? Okay, so we're gonna show you tomorrow. We're gonna start tomorrow.
Not past the last year. You throw a marker every day.
I didn't do a marker every day. I do it every other day. Oh, I do it every day to Ian.
Yes.
Ian would know. It's not you. It's Ian or Bennett.
Yeah. Oh my gosh, finished.
Okay, cool. What do you guys see? Portuguese. Portuguese.
Don't remember if it's second or third.
Third. Oh, it's hurricane. Not bad.
No.
Falling down on the roof.
No. Is your roof okay?
Yeah.
That's good.
And you have to go over those tree falling on my car.
On your car? Do you have insurance?
Yeah, but it's a shitty car, so.
Oh. Did you get a new car?
No, it wasn't bad. It wasn't like not destroy the car, just make it better.
Do you still have that car?
No.
Do you have a new car?
Sold it for a long time.
What do you have right now?
Mine? Honda CRV.
You look like you'd be the type of person to have like a Tesla or something.
Me? I can't afford Tesla.
I was gonna say.
It's too expensive for me. And that's also too fast for me because I actually want to buy it for my wife. But she doesn't like those braking because when you let go, the brake kind of like this. I don't know if you ever drove a Tesla before.
No.
No? You don't know.
William drives a Tesla.
Yeah, that rich kid. not be rich kid.
No, he's not even salty.
No, he's not. He's not. William's
Yeah.
really nice. William's like really nice.
Like the sweetest thing ever. It
Yeah.
like makes me concerned.
Huh?
Like it makes me concerned about him.
Why?
Cause like, what if someone's like really mean to him and he just doesn't say anything?
I can imagine find a very mean girlfriend and just kind of boss them around. I can see that
I
too.
can see that. I can see
And you'll be like, okay, yes, ma'am.
that. Yeah. Like, no, you can't say that. Like I told him, I was like, you're too nice. Like
Yeah, I definitely think